Okay, students, this is your well-rounded math teacher, Mr. Picard. Pretty handy with a spoon if I don't say so myself. And today, we're going to finish up the notes on common logs and natural logs, which you should know the buttons for on your calculator and how to use them. Anyway, we're going to start out with a shout out here. So this shout out going out to all the students in my class right now that don't play baseball. So anyway, we're going to solve this exponential equation. It's an exponential equation because there's a variable as an exponent. But the deal is you have either a natural log there. So we're going to have to use natural logs to solve this equation. The first thing we're going to do is get that e to the x by itself. And the way we do that, well, first of all, we're going to subtract 2 from both sides. 3e to the x equals 2. And then divide both sides by 3. And you can leave it as a fraction. It's not a big deal. So the natural number e to the x power equals 2/3. Now the inverse of e is the natural log. So in order to solve this now, to finish it off, I'm going to take the natural log of, can I move this over? No, I can't. I can now. Natural log of both sides. When I do that now, I can take my x and put it out front because it's an exponent. This is x times the natural log of e equals the natural log of actually 2/3 in parentheses like this. The natural log of e itself right here, that's like the log base e of e. Well, this is going to be equal to 1. So this whole thing cancels out to 1. 1 times x is just x. So basically, you just have to take the natural log of 2 divided by 3 on your calculator, and you should get negative 0.4055. So try that real quick and make sure you get that for an answer. And here's another one that we're going to have to use the natural log because it has natural number e on there. So we're going to add 9 to both sides because we want to get that e to the negative x by itself. So 4e to the negative x, we'll worry about that negative in a minute, equals 7. You're multiplying 4 times e, so we're going to divide both sides by 4. E to the negative x equals 7/4. The inverse operation of using this e here is taking the natural log of e. The natural log of e is equal to 1, so it's kind of nice to use. And we're going to bring that exponent down. And it's going to be negative x right here times the natural log of e, which is 1, so I just get negative x. And then we have to take the natural log of 7 divided by 4 on your calculator. So we get negative x equals 0.5596. Dividing both sides by negative 1 or multiplying both sides by negative 1, it really doesn't matter. X equals negative 0.5596. And there it is. I told you sooner or later we'd get to the point where we have to use logs and natural logs. You guys learned about natural logs today to solve exponential equations. And now we're going to get into the real world part of it. Oh sure, everybody loves pi, but sooner or later their interests converge on me. It's a pretty good one, no big deal. And we're going to use this. It's called the APERT formula. APERT formula is used when you're finding compounded continuously, interest compounded continuously. Anyway, when interest is compounded continuously, the amount A right here in the account after t years, t is time in years, is found using the formula A equals P, capital P, E to the RT power, R and T to the power here. There's my rate, and there's my time. P is your principal. That's the amount that you plug into the bank right away. And R is rate, or your annual interest rate. So APERT formula, you'll hear about it off and on from now on. So let's get rid of that joke for a second there. Here we go. Suppose you deposit $1,000. That's your principal in an account paying 2.5% annually. Annual interest, compounded continuously. As soon as it says If it says compounded, you just use the compound interest formula, but when it says compounded continuously, that's where we're going to use APERT. Okay, and we're going to have to use some logs. Well, maybe not, we'll see. So first of all, my principal is 1,000 times E, natural number E. R, my percentage is, okay, you got to be a little careful with this. Move your decimal over twice, or just divide this by 100. Percent is per 100. 0.025 is what you'd get, times the time. And let's deposit count compounded continuously. So they don't give us a time. So I'm just going to put T there. Now, what that actually is A equals 1,000 E to the 0.025 T power. So I could plug in any time now and solve this equation. Okay, so what is the balance after 10 years? Okay, plug in 10. A equals 1,000 E to the 0.025 times 10 power. So that's 1,000 E to the, okay, 0.25 power. 0.025, you're basically moving your decimal over 1 when you multiply it by 10. So we get 0.25 power. Now, this is what you're going to plug into your calculator. You have to use the natural number button, the E button on your calculator. Should be like e to the x or something like that. So it's going to be 100 times E, hit the E button. And you should, if it's e to the x, you should get, it should pop up in a box like this. But if it doesn't, some calculators, you're going to have to put the caret key in there and put 0.25. But most of the time, when you're using that E to the X button, there'll be a little box there, and you just plug in 0.25 and hit enter. You should get $1,284.03. That's how much you'd have after 10 years at 2.5% interest. Not a lot of gain for 10 years, but 2.5% interest isn't that much. Now, it's pretty easy when they give you the time and the interest rate and your principal. Now I'm going to give you a problem where we have to find one of those. And we're still going to use the APERT function. So how long would it take for your balance to reach at least $1,500? Okay, so that's A. When we're looking at APERT, whoops, right here, your final amount, you want it to be 1,500. So I'm going to plug 1,500 in here for A. I want it, it started out with 1,000 still, so that's my principal. This is E to the, okay, same interest rate, 0.025 T power. We want to find time now. I know what E is. It's a natural number, 2.81, something like that. So here's how we solve this. We want to solve for T now. First thing we're going to do is get rid of 1,000. So I'm going to divide both sides by 1,000. 1,500 divided by 1,000 is 1.5 equals E to the 0.025 T power. Okay. T is in the exponent. This is an exponential equation working with the natural number E. We got to get rid of E, so we're going to use its inverse, which is the natural log. I'm going to take the natural log of both sides here. So I'm still going to have the natural log of 1.5. When you take the natural log of E, it cancels out to 1. But before it does that, I'm going to take this and put it in front and multiply by the natural log of E. So basically, I got 0.025 T times natural log of E, but this is equal to 1 again. So this is what I'm left with. I want to solve for T now. I just divide both sides by 0.25. 0.025, sorry. So T equals, type in the natural log of 5. And if you want to do it on your calculator, plug this whole thing into parentheses, then hit the division button and plug in 0.025, and you should get roughly 16.22 years. A little over 16 years to get $1,500 in your account. And that is it for right now. If you have not watched the first half of this notes, I want you to watch that. And you can start working on your worksheet. Don't forget your note sheet 9-6 for tonight. I'll see you tomorrow. Got some stuff to do. Sorry. See you there. Bye.